Çok
Kanalımız rating düşürüyor.
Hi everyone, I am Metan and my teammates are Mert and Furkan. We are talking about our machine learning model. It is full type classification. And now I start some information about our project and our dataset. We know that global warming has become a serious problem in today's world. One of the main problems of this situation is air pollution, which is the increase of carbon monoxide density in the air. One of the main factors causing this is the exhaust emission of vehicles used for transportation. Especially vehicles using diesel fuel emit exhaust gas. As a matter of fact, the decision to ban diesel vehicles was brought to the agenda in 2018 due to the fact that the amount of nitric oxide detected in the air in some cities of Germany exceeded the limits set by the European Union and caused deaths. Our goal was to develop a machine learning model that predicts the type of fuel based on the technical characteristics of the vehicles. In this way, it is aimed to detect gasoline and diesel vehicle and prevent the use of diesel vehicle in the market. And our dataset collected from categorical classifier at for CAS dataset. This dataset has been scraped from websites in Czech Republic and Germany. Now continue with our features. Our dataset has 16 features and one of them is target. And at first our dataset has 3 million sample. Firstly, maker is company name of producing the cars like Skoda, and it is categorical feature. This feature has 519,000 missing value, and maker has 46 label, and most common is Skoda. Model is model of the car, like Octavia, and its categorical feature. And this feature is about 1 million missing value, and it has 1,012 label, and most common is Octavia. Mileage is miles of vehicle in kilometer. It has 300, and it is a continuous feature. It has 363,000 missing value, and it is ranged between 0 and 10 million. And manufacturing year of the cars. And this is a continuous feature. It has 371,000 missing value, and its range is between 0 and 2017. Engine displacement is capacity of engine in cubic centimeter. This is continuous feature. It has 743,000 missing value, and it ranges between 0 and about 33,000. Engine displacement, engine power is the maximum power that an engine can deliver in kilowatts. This is continuous feature. It has 555,000 missing value, and it is ranged between 1 and 2,237. And body type is the type of car like sedan or hatchback. It has about 1 million missing value, and it has 9 label, and most common label is other. Other means unknown, means null, and so it is additionally missing values, and our missing values about 90%. Now continue with color slug. It is color of car. It has about 3.5 million missing value, and it has 14 label, and most common is black. CTK year is year of the last emission control of cars. This is continuous feature. It is missing about 2 million data, and it has 232 label. Most common is null. It means null. Again, it means missing values. And transmission is transmission type, as we see in automatic or manual. It is categorical feature. This has only 2 labels and 742,000 missing value. Most of the cars are manual. Door count is number of door in the car, and it is categorical feature. It has 614,000 missing value and 19 label. Most common is 4, and also this is general situation for the cars in today's world. Seat count is the number of seats in the car, and it is categorical feature. It has 749,000 missing value and 58 labels. Most common is 5. Also, we know that seat count is generally 5 in the cars. Flu type, type of fuel in class, it is an target class, and it is categorical feature. It has 749,000 missing value and 58 label. Sorry. It is, sorry, karıştırdım hocam biraz. It is about 2 million missing values. We eliminate it, and it has 1% electrical car and LPG and CNG cars, totally not 1%, and this is also our target class. But not this situation, this is our target class, because we eliminate electrical, LPG and CNG and drop missing values. After that, we use that. Date created is when that was skipped, first skipped. This is continuous feature, and it has no missing value. And date last seen is when that was last seen. This is continuous feature, and it has no missing value. Price euro is this price converted to euro. This is continuous feature, and it has no missing value. Now continue with dropping columns. We drop maker and model feature has more label. Maker has 46 different label. Model has 1012 different label. And additionally, in the future, maybe new models and new makers founded if you want to develop and if you want to develop more general machine learning model, so that we drop this feature. Additionally, body type, color slug, and STK has more null values, so that we drop these features. Finally, date created and date last seen is only scraping dates, and they are uninformative for our ML project. And dropping sample, we drop some samples of for target class. Our full type includes 50% null value, so we drop these samples. We see that electrical cars only 1%, CNG and LPG 0%, so that we eliminate these labels. After this work, we has only 2 labels, gasoline and diesel, and we know that label's name, and this is supervised, only 2 label, binary classification. So our problem is supervised binary classification. Now continue with data cleaning. We clean our data set 4 times, and we clean this data set on Kaggle. We explain this data cleaning step also in Kaggle. If you want to see data cleaning all steps, you can go to following link. Now continue with some steps of cleaning data. We check our dataset general information with describe function, but we explain these features on the next slides. We want to drop body type, color slug, STK, date created, date last seen features with this code. After this work, we eliminate our target class. We drop full type null samples, electric labels, and LPG labels, CNG labels. After this, our target class only has gasoline and diesel. We see that on the left side, full type is not null. It's 0. And right side, general information about our dataset. Objects see that categorical feature. Float see that continuous feature. And in this time, our dataset has about 2 million entries and samples. And continue with next slide. Unified variable it is general visualization of a feature. In here, we visualize fuel type feature, and we see that this feature is only 2 labels. They are also diesel and gasoline. Diesel is 46% and gasoline is 54%. In Kaggle, we check relationship between our target class and features. Only 2 of them is here. Firstly, transmission. After basic data analysis, results is manual automobiles much more gasoline and automatics are more diesel. But it is too close to each other, so that we can't say it is always true or false. And additionally, we change our full type 0 and 1. 1 million is gasoline, and 0 mean is diesel in here. And second one is door count and fuel type. We see that 22 doors every time gasoline. On the other times, on the other hand, 17, 9, 7, 45 door count, always diesel. And other can be changed in basic data analysis. Now continue with outlier detection. First, we want to outlier detection want to first quantile, third quantile. After that, use them and find EQR and return an outlier list. Additionally, some values in the outlier list are maybe important for our ML algorithm, so that we add a filter, a sample, at least three different feature goes to outlier. After that, drop this sample. Otherwise, this value may be important and this is not go to outlier. Right side is the outlier list. On the below script is drop sample. In here, we bigger than 2. This is a filter for outlier sample. And missing values. First step is find null values in a list we select model feature. Second step is find right type site, a function, fill null values on one fill null values. Fourth step is in a for. We call the function and we fill model feature with using maker, fuel, and manufacturer year, because they are uncorrelated with model feature. After 20 hours, this filling is completed. Only one missing process in here. You say that you are not using model feature, why fill it? Because after this work, we fill mileage with using model and manufacturer year. We fill manufacturer year with using mileage and model, so that if you want to more generic fill missing values, we don't ignore model feature. After that work, dataset has few null values. We drop null samples in left side. Finally, our dataset has no null values on the scene right side. This work, we take the dataset Kaggle and continue with orange tool. Additionally, we control related works on Kaggle kernels for our dataset. There is no work about machine learning prediction, and there are only 5 different kernels, and only one of them writes something. Other kernels are empty. Now continue with Furkan dataset analysis in orange tool.
Hello everyone, my name is Furkan. I will talk about data reading now. We use file widget to read our data in Orange Tree. After pre-processing phase expressed by my friend Metehan, our dataset now has 12 columns. Here we are dropping maker and model features since they are too specific. In other words, there will be new makers and models in future, and they will not match with the classes in our training dataset. Thus, dropping these 2 features will make our model more generalized for the possible new brands in next years. Also, we have dropped the fuel column since it was created artificially while pre-processing in Python. Here, the label 1 means fuel type of gasoline and label 0 means fuel type of diesel. Since we have our target called fuel type and it is showing values exactly the same values of 0 and 1, there is no need to include this feature into our model. Data info and data table. In the right side, we see our Orange Tree data info widget, which shows our dataset name, size, and other information. As a result of pre-processing steps and while reading the data, our dataset got shrunk to 9 columns in total. These columns show 8 features, where 1 of them is categorical feature and 7 of them is numeric features, and a target with 2 classes. Also, our dataset now have 521,694 samples in total. Here we can see a part of our dataset. Our categorical feature is transmission, which has 2 labels of auto for automatic transmission and man for manual transmission. Also, we have 7 other features with numeric data type. They are mileage, manufacturer year, engine displacement, engine power, price, euro, door count, and seat count. That we can see them in here. Now, correlation. This is the correlation widget on Orange tree. Correlation shows the relationships between each feature within the scale of -1 and 1. If correlation value is close to 0, this situation shows these two features are uncorrelated. If correlation value is close to 1 or -1, this situation shows these two features are correlated. When we consider the most correlated two features, which are engine displacement and engine power, the combustion of the fuel occurs in piston housing, and when the piston displacement or engine displacement increases, the engine power also increases proportionally because the fuel combustion gets more and more for per stroke of piston. Thus, engine displacement and engine power features are correlated, highly correlated. Also, if door count increases, seat count increases, which is a basic rule of cars. Thus, these two features are correlated. Other features are relatively uncorrelated. So our dataset features are used together, and we are expecting meaningful predictions from our machine learning algorithm with these features. Fuel type distribution. Our target has two labels with so close frequencies. If it wasn't this way, our machine learning algorithm would ignore the labels. For instance, if two label frequencies would be 1% and 99%, our machine learning algorithm would ignore 1% label. But this is not for our case. Our data set is balanced and it works well in real-life applications. Mileage distribution. The table here shows the distribution of our mileage feature. It is split by our target labels, where blue indicates the diesel fuel type and red indicates the gasoline fuel type. When we look at the mileage value, we can see that almost all cars, I mean 99.79% of our data set, have a mileage value less than 400,000 kilometers. And if it is between 2 and 400,000, that we can see here, we can see that vehicles with fuel type of diesel is dominant. Considering these, we can see that in general, diesel cars have more mileage than gasoline cars. Also, in here, if we take a closer look, we can see that blue line is slightly further than red line, which means the same thing expressed above, which is in general, diesel cars have been used more than petrol gasoline cars. Manufacturer year distribution. The table in here distributes the gasoline and diesel cars with respect to year that the cars have been manufactured. We can easily see that our data set has more diesel cars when manufacturer year gets closer to date. Looking at it, we can make a comment in the light of our data set, of course, as the new cars are being manufactured with fuel type of diesel more than gasoline. Engine displacement distribution. The table shows the distribution of our engine displacement feature. It is split by our target labels. Again, blue indicates diesel and red is for gasoline here. We can observe that our data set has more diesel cars when engine displacement gets higher until the value of around 4,000 cubic centimeters. Also, if we check further, we can see that diesel engines has mean displacement of value 2,028 cubic centimeters, where it is 1,660 cubic centimeters for gasoline engines. Looking at these, we can make a comment in the light of our data set, as the cars with higher engine displacement values have more probability of using diesel rather than gasoline. This is our scatter plot before and after preprocessing. The scatter plot on the left is absolutely uninformative for us, and it is also scattered very sparse. After preprocessing, a scatter plot has obtained, and this plot is more meaningful in the right side than the previous one. For instance, a polygon shape can be created for diesel label, and the area outside of this shape can be assigned as gasoline. However, there are still some sparse data for the preprocessed plot. For this reason, it is almost impossible for us to predict and develop algorithms using only these two meaningful features. Now, feature constructor, we use this widget, the feature constructor widget, to add some new features into original dataset in Orange 3. In our dataset, there was the mileage feature, which was indicating the total mileage value for the used cars. However, these vehicles were scraped from the websites in an interval of timeline. Since the scraping date was not same, the mileage values would be misleading or misguiding for our machine learning model. Also, in real-life testing, the prediction would be expected from our model in different years, like 2020 or 2025. Thus, if we divide it to the years that the car have been used, mileage feature would be more generalized. By doing it, we can find mileage per year value for vehicles, which is a better feature than mileage itself when it is considered logically. Our formula for the new feature is the mileage value divided by the subtraction of 2018 from manufacturer year value. We used 2018 since it was the last date the data was, since it was the last date scraped from the websites was 2017, and we tried to prevent division of 0, so we chose 2018 while using this formula. Now, preprocess, as my friend Metehan told, some parts of preprocessing was made in Python before the dataset loaded to Orange 3. In here, we will clear some data directly instead of filling them with reasonable values. Thus, select rows widget in Orange 3 has the enough capability of doing the clearing data operation in a more comfortable way. When we examine our door and seat count features, we saw that some samples had values, but instead of a number, they were non-values. Also, in the manufacturer year feature, there were some irrelevant values. Since we know that first car was invented around the year 1900, and it is impossible to be manufactured in the future, like 2021. We selected the interval of 1900 and 2020. We have selected these samples and made the clearing of irrelevant samples from our dataset. Now, what is the edit domain and why we have used it? Edit domain is a widget that helps us while transforming the feature types between categorical and numeric. We use the edit domain widget to transform the feature types of door count and seat count from categorical to numeric to obtain more homogeneous feature labels, like merging two labels of 1.0 and 1 and get one only value, get 1 as an only value, or here 4.0 and 4 to get 4. Otherwise, there would be two different categorical values with exact same meaning for both. That's why we used edit domain. We used rank for feature selection. It shows the correlation of each feature with dataset. There are several types of ranking methods. We chose information gain for our dataset. This method is reduction of entropy. In our dataset, none of the features is enough alone to train our model or solve our problem. Now my friend Mert will continue.
Thank you, Furkan. Hello, everyone. I am going to start by talking about the machine learning model we have chosen and why we have chosen it. When we first look at the features of our dataset, we saw that we had almost 100,000 records and 8 features. So we first thought that linear models would work better for us. However, we realized that linear models would not be an effective decision boundary, as our feature number was low and the distribution was concentrated in a certain area. Also, our problem is a classification problem because we want to estimate diesel and gasoline vehicles. Linear regression was not preferred among linear models because our problem is another regression problem. We didn't choose SVM from the linear classification models because we know that it creates problems with runtime and memory usage in large datasets. As a result, we choose random forest, an algorithm that can bring good results in a large dataset and low dimensional datasets. Besides, we observed that the algorithm in the tree structure produced more successful results in our dataset. We know among the algorithm in the tree structure that the random forest is stronger than the decision trees. We added two models to J-in for observation. In the results, we wanted to show that random forest produced more successful results than the decision trees in our dataset. And for this reason, we prefer random forest from tree-based models. And let's continue with the next slide. And we applied Continuize. In our dataset, we wanted to convert three categorical variables to numeric variables. We realized that categorical variables are more meaningful to us when they act as numerical variables. That's why we choose Continuize, one of the preprocessing widgets available in the orange tree. During the process, we used trade as an ordinal in order not to change the dimension of our dataset. And let me tell you what the trade as an ordinal option does. Trade as an ordinal takes discrete values and trades them as numbers. If discrete values are categories, each category will be assigned a number as they appear in the data. And you can see our transmission data and manual and automatic converted to 1 and 0 because they are in categories and changed to numeric values. We have not applied any scaling operation to numeric values since it can work very powerfully in the random forest model without scaling. And another slide we can go, and we use data sampler. We reserved 4% of data set for test before testing data, and it's 2000 data. Then we split the remaining data into 70% for train data and 30% for the test data. One of the important things that we mentioned here was that we choose replicable and stratify. And replicable provide us for shuffles dataset with a pseudo-random, and stratify give output same target distribution similar with other. And we use this because we can get similar results for every step, every train. And our selected ML machine learning model is random forest. And one of the most important parameters when tuning in random forest is number of attributes considered for each split. Because if we leave this value, the same number of features in the data set, all the features in each split will be looked at, and therefore no randomness will be injected. If we keep this parameter value too high, every tree in the random forest will be similar, so it can fit more easily with the data. If we keep this parameter value too low, when the trees in the random forest will be quite different, and each tree will be have to too deep to fit the data well enough, and it causes smaller, and because of that, smaller number of attributes reduces overfitting. So the formula we use for this parameter to find the ideal value is square root of our number of features for classification. And if we use regression, we use logarithmic, take logarithmic of number of features. Also, we select replicable training, give it pseudo random, so run every time reproducibility of the results. And we also show the decision tree parameter tuning, just showing them. It is not our target model, but we applied pre-running because for prevent our tree model to overfit. Because of that, we added some parameters. The parameters that control model complexity in decision trees and are the promenic parameters that stop the building of tree before it's fully developed. If we didn't do that, unpruned trees prone to overfitting and not generalizing well to new data, and it's going too deeper. And we select induced binary tree because we're splitting about 2 child nodes, and minimum number of instancing leaves we checked because the algorithm will never construct a split which will put less than specified number of training examples into any of the branch. and target class is 2. We select 2 minimum number of instance leaves. Do not split the subsets smaller than. We select 5. For the algorithm to split the nodes with less than the given number of instances. And we didn't change because if we increase this value, it can be overfitting, and this is the ideal value for our model. And limit the maximal tree depth. Limits the depth of the classification tree to the specified number of node levels. And okay, and we stop the majority when we reach the 95%. This is our parameter tuning for decision tree model. And to train our data set, we use data sampler to divide 70% for training and 30% for our test data. We trained our model with training data and used orange tree test and score widget to see the validation test data results. Our model, which we created as a result of parameter tuning, has achieved 98% test data success and also decision tree success with 98%. We have applied cross-validation to see if the model's high success is random. Cross-validation has allowed us to see if we are facing a problem of overfitting and the quality of our model. And you can see we applied cross-validation with tenfold and the results here, and they are close to each other when we apply the train on train data, actually train on test data, close to each other, and our model is not overfitting for that. Also we use the prediction widget to test the 20,000 data we have reserved for test. We sent the model we trained and the data we reserved. As a result, our model has achieved a 98% success. To evaluate this success, we looked at the results with the confusion matrix. Of the 9,645 diesel cars, 9,475 were correct, and the remaining 170 were not known. Likewise, it predicted 201 of 11,223 gasoline vehicles in our dataset incorrectly. By using the formula for accuracy, we wanted to calculate accuracy. As you can see on the slide, the true positive is 9,475 and the true negative is 11,022, and accuracy is the 98%, which is the percentage of our model success. And in order to use the model we created later, we saved our model on an external disk. Thus, we will not waste the time to retrain the model in the prediction we will do later. In Orange 3, the model can be saved and reloaded using the load model and save model widgets. And this is the flow our training when we used and widget we used. And my friends and I talk about the most of widgets we have been using so far, but I would like to mention some of important widgets have been using again. First, we loaded the files and selected the features we are going to use. Then we cleared the values, entered with none with select rows. Then we got rid of the problem we had with values like 4.0 and 4, and using the edit domain widget, we made it one value. We used the feature constructor to create meaningful features for the model to be used in predictions, and we created a new feature to estimate diesel and gasoline vehicles for the model. We have added a feature that explains the vehicle's average mileage every year. Then we extracted high correlations for one of our variables. Using the Continuize widget, we transformed 3 categorical variables, divided our data into train and test data with data samplers, and gave it to our model. Then we saved the model and tested it. We collected real data from the internet. Using the confusion matrix, we evaluated the results. And the last part and the most exciting part, I think, we gathered 33 car data from the Sahibinden.com and Schuhen mobile DA to test the model we created in real life conditions, and we gave them to our model for estimation. Our model couldn't correctly predict just one of 33 cars, and it is estimated gave 97% classification accuracy. We have thus seen that the model we created can be used in real life and is a generic model. And thank you for listening us. We can accept your questions.
Okay, thank you for the good presentation for all. Now I have several comments before the questions. My first comment is that you are supposed to do everything inside the orange environment. Why did you choose the Python?
Hocam Türkçe cevaplayabilir miyim?
Yok,
Başta da
İngilizce konuşalım, oldu mu?
Ha, tamam. In our process, we don't know orange tool especially. After that, we learning depth and depth. And first, we collect data so that we some changing like missing values. We doing Python.
Okay, I wonder that if there is anything that you cannot do in Orange, but you can do in Python, is there any difference between? Okay, so I think that you can do everything, whatever you do in Python, you can apply the same ideas in Orange as well. Is that right?
Yes.
Yes. So in your final report, I would like to see the orange environment only, okay? Because in other teams, they apply the same ideas in orange. So our aim is to show that you can do everything in orange environment without coding in Python, because otherwise the other guys can apply Python as well. But we restrict ourselves to orange because there are other disciplines. So we have the students among us from the other disciplines. They don't know how to code in Python. Okay. So my idea is that everybody will use orange and it is widgets. Okay. So I would like to kindly request you change the pre-processing steps into from Python into orange. Is that doable? Can you do it?
Some of the do it, but I don't know how to fill missing values with other features.
We have the pre-process widget in the orange tree, so you can use it, I believe. Huh? So just check it. If it is too much burden for you, just ignore the some steps. But in your final report, I would like to see only the orange tree environment, okay? Otherwise, it turns out to be that it's a free project environment, but it's not free project environment. We are restricted using orange tree because all the teams or the project teams, I mean, should have the same environment to compare the what they understand. So the Python is not important for us for the moment, but the ideas and how to implement the ideas by using a simple widgets is important. Okay, so this
Sir,
is my...
May I have a few words about it?
Yes, please.
My name is Furkan. Sir, as I know, the orange tree has the future, I mean, we can construct, we can adjust the features, we can delete the missing values exactly, and we did already, but filling the missing values with respect to other features, with getting the information from the other features is not really applicable with the orange, as I know, and my friends were told the nearly same way with this. So we the data set that we obtained was a real problem. It was really problematic. There were so many missing values, and the features were limited. There were around 16 features, and not all of them were available. Not all of them were informative for our model. That's why we tried to, especially my friends Metehan and Mers, tried to fill the missing values in the Python environment.
I understand your point, but what I am trying to say that in Orange Tree you can fill the missing values with some formulas as well, and you can use the feature constructor for filling the missing values. Actually, isn't it right? So you can use the feature constructor to fill the missing values. So you can use two different features, and you can do it. But give a try it, okay?
Okay,
so,
okay, sir, we will try, of course.
Because my idea is that using the same tool for each team. Otherwise, tomorrow some idea comes and they said, oh, Python is not enough for me. I would like to use the .ml. And somebody says, no, I will use R. So
Yeah,
I cannot manage all these kind of differences, because my idea is to teach you the fundamentals of the machine learning algorithms and how to implement in real life scenarios. But
yes,
our aim is not to implement everything in Python. So I know that you have the capability as a computer engineers, as a software engineers. I know that you have the capability to do it, but I try to keep the things, the development environment simple, so that
yes,
you can focus on what you are doing. Okay.
yeah, yes,
so please try to do your best for completing the project within Orange environment. All right.
Okay, and if I would add a few words, it took so long time in Python itself. It was around 20 hours to fill only the one feature, the missing value of only one features, only one feature. So it will be a bit hard for us, but we will try our best. So.
Okay, so let me finish this discussion with that, with a conclusion. So if you think that it is very vital to use Python because of these performance considerations, do it on Python. But then for the simple steps in Python, please carry these steps to the Orange, okay? But maybe some steps could be still in the Python, okay?
Yeah.
Do you understand? But most of the steps can be done without any effort, extra effort in Orange. Is that right?
Yes.
So
like
for example,
dropping the features directly.
Yes, for example, you provide some screenshots. Can you go to the first 5-6 slides?
Yeah, of course.
And the first 5-6. Okay.
I'm going.
Yeah, stop here. Okay, go down. Look, these are from where? This.
Kaggle.
Yes. So what I'm telling, it should be from Orange. These screenshots must be taken from Orange. Do you understand? So this is simple. You can provide the same screen, right?
Yes.
Yes.
So you understand what I am talking? But maybe there will be some steps you explained already. Okay, I understood. So you can use the Python for very few steps, but for the simple pre-processing like this, okay? So you can use the Orange. Are we all agree?
Yes, sir.
Any problem with that?
No.
Okay. The second thing is that for your presentation, actually, for me, it is a little bit complicated to follow you what you have done for the pre-processing. You mentioned a lot of things about pre-processing in different places in your presentation. So please think about this and put the simple explanation. We do first this, then this, then this, then this. At the end, we end up with this number of features and we continue our test. But I couldn't follow easily what are the steps for pre-processing? There are lots of things you have done, but I lost the sequence. Do you understand?
Yes, sir, you're right. And this is also related with the Python usage. And if we do the same thing that you told, using Python as low as possible, I think it will be solved too.
I think so. Okay, I think so. So please, before the final report, working on it. Okay, so work out on it. Okay, so other comment. I think you have only 9 columns at the end, 9 features. Is that right?
Yes.
Did I understand correct?
Yes, 8 features and 1 target.
9 features.
No, 9 columns with 8 features.
Okay.
8 features,
and 1 target.
8 features, 1
target.
8 features.
Yes.
So the dimensionality of the data set is very, very low. Is that
Yes.
right? So why didn't you apply the interactions and polynomials to expand the features?
We tried some linear models, and we get, and for example,
No, I am not talking about linear models. I am talking about feature processing or feature engineering. Why didn't you increment the number of features by applying polynomials and interactions? Remember in the course, we did it in the last week. Okay, please take note this, okay? Before the final report, you might add new features by applying feature interactions and polynomials ideas, okay? Please do it. For the distributions, you show lots of slides for the distributions. At the end, what did you do with that distributions? We have seen lots of distributions for all the features. Then what? What did you decide?
We can see our data set is
okay,
balanced.
For that one, for example, I am sorry I interrupt you, but look at this one. And what you do, if I were you, this millage, I understand that I need to use power function to make the difference higher between here. It looks like log scale. Is that right? So, for example, I can apply the power function for that. So I can see the difference between 0 and 1, whatever the millage is that, okay, on the x-axis. So I can get zoom into that data by using the power function, but you didn't. Can you go to the manufacture? What is that? Manufacture here. So if I were you, I would drop the data less than, for example, 1980s. Less than. I can remove. Did you do this? No.
We did. There were so many classes here, sir, from the 0 to almost 5,000. We tried to give a logical.
Where in the presentation did you talk it?
Yeah, I told it. It was as I told. It was from the 0 to 5,000, and we restricted them between 900 and 2020.
Okay. What about the previous slide?
Previous? Which?
Previous slide.
This one?
Here, for example, did you apply any here?
Yeah.
Yeah. Did you apply any transformation here? You can do the power transformation here, right? It's log scale. You see that? It's log scale. So check this and this kind of things. You need to apply some transformation because the data is skewed, very skewed, between 0 and 0.3 or something. Do you understand what I am talking?
Yes.
So you have to do this. Now you have to do. You have only 8 features, but applying these transformations, you can increment the number of the features as well as their meaningfulness. All right. Please note this as well.
Yes.
And for the cross validation, you have the one slide for the cross validation. here, I see that on the right side, bottom line, there are on the bottom there are two results on the bottom, but none of them is for cross validation. So I didn't understand this slide. What we are comparing with what? Okay, this is cross validation for what? Train set or the test set?
Test set.
At the bottom was?
This one is test on test data set, and we want to show the cross validation on the data set and test data set.
Can you show me with your mouse? I couldn't.
Yeah, this one is test on test data, and this one is test on train data.
And cross validation is?
Cross validation is here.
Test on test data or train on?
For test data.
Oh, it's oh, sorry. The headers are not correct. Train on train data, train on test data.
Test on train data, test on test data.
Yes,
is that
yes,
right?
yes. Yeah.
It's confusing for me. I couldn't follow you. I couldn't understand what's going on there. Okay, so please pay attention what you are writing and what you are explaining. Okay, so yes, I will check my other. Okay, so for the results, why didn't you use SVM? And what happened to the SVM? What was the result for SVM?
And for SVM, we get 60%.
The classification accuracy is that?
Yes, classification accuracy is 60%.
If I am not sure for that, but if you please work on with the incrementing the number of features with some interactions and polynomials, try to work on SVM as well. I believe that it will end up with much more classification accuracy in the end, if you work on this. Okay.
Yes,
so my questions concludes like that, Tolga?
Actually, all of my questions are asked by Madhuja.